Hello everyone, this video is about the life cycle assessment of a cheese. This video contains a brief introduction to cheese, the life cycle of cheese, environmental impact, mitigations, and the conclusion. Cheese is a nutritious food that conserves milk and contains proteins, minerals, vitamins, and milk fat. However, as concerns for the environmental impact of industries increase, products like cheese will have a significant environmental impact. Therefore, LCA studies on the environmental impact of cheese production must be conducted. The actual time and place of the origin of cheese and cheesemaking is unknown. The practice is closely related to the domestication of milk-producing animals, primarily sheep, which began 8 to 10,000 years ago. First cheese was probably produced in a ruminant stomach that is used as a storage vessel for milk. Now, let's take a look at life cycle assessment of a cheese. The life cycle of a cheese contains 6 stages which involved from the cradle to grave processes. It begins with raw material, manufacturing processes, packaging, distribution, use, and the final stage is the end of life of the cheese. The main ingredient in cheese is milk. Cheese is made using cow, goat, sheep, water buffalo, or a blend of these milk. The type of coagulant used depends on the type of cheese desired. For acid cheeses, an acid source such as acetic acid, the acid in vinegar, or gluconodelta-lactone, a mild food acid, is used. For rennet cheeses, calf rennet, or, more commonly, a rennet produced through microbial bioprocessing, is used. On the other hand, flavorings may be added depending on the cheese. Some common ingredients include herbs, spices, hot and sweet peppers, and horseradish. There are 12 stages in cheese manufacturing. The stages include standardized milk, pasteurizing milk, cooling milk, inoculating, add rennet and forming curd, cutting curd and heat, draining whey, texturing curd, dry salt or brine, forming cheese into blocks, store and age the cheese, and finally pack. Now, let us take a look at the details of these processes. The first one is standardized milk. Milk is often standardized before cheesemaking to optimize the protein-to-fat ratio to make a good quality cheese with a high yield. Next, pasteurize or heat-treat milk. Depending on the desired cheese, the milk may be pasteurized or mildly heat-treated to reduce the number of spoilage organisms and improve the environment for the starter cultures to grow. Some varieties of milk are made from raw milk, so they are not pasteurized. The third stage is cooling the milk. Milk is cooled after pasteurization or heat treatment to 90 F30°C to bring it to the temperature needed for the starter bacteria to grow. If raw milk is used, the milk must be heated to 90 F30°C. Then, inoculate with starter and non-starter bacteria and ripen. The starter cultures and any non-starter adjunct bacteria are added to the milk and held at 90 F30°C for 30 minutes to ripen. Next, add rennet and form curd. The rennet is the enzyme that acts on the milk proteins to form the curd. After the rennet is added, the curd is not disturbed for approximately 30 minutes so a firm coagulum form. After that, cut curd and heat. The curd is allowed to ferment until it reaches pH 6.4. The curd is then cut with cheese knives into small pieces and heated to 100 F38°C. The heating step helps to separate the whey from the curd. Then, drain whey. The whey is drained from the vat and the curd forms a mat. Next, texture curd. The curd mats are cut into sections and piled on top of each other and flipped periodically. This step is called cheddaring. Cheddaring helps to expel more whey, allows the fermentation to continue until a pH of 5.1 to 5.5 is reached, and allows the mats to knit together. The 9th stage is dry salt or brine. For cheddar cheese, the smaller, milled curd pieces are put back in the vat and salted by sprinkling dry salt on the curd and mixing in the salt. After that, form cheese into blocks. The salted curd pieces are placed in cheese hoops and pressed into blocks to form the cheese. Last but not least, store and age. The cheese is stored in coolers until the desired age is reached. Depending on the variety, cheese can be aged from several months to several years. Finally, package. Cheese may be cut and packaged into blocks, or it may be waxed. For the packaging stages, most cheese varieties are packaged in plastic film or aluminum or tin foil. Cheese is primarily transported in cartons. Sometimes cheese is also transported in rolls, which are wrapped with paperboard and strapped with metal strapping. To protect it from theft and damage, cheese is also transported in mesh containers, lockable box pallets. The transport uses normally are ship, truck, railroad, and refrigerated containers. Cheese in rolls must not be dropped or set down hard, as it could thereby lose its roundness. It is also imperative that the goods be protected from moisture, rain, snow during cargo handling, and from excessively high temperatures. It is absolutely essential to comply with the specified refrigeration temperature. The storage space requirements must be cool, dry, and well ventilated. Finally, the last stage in the life cycle assessment of cheese is the waste generated. Waste generated at the household included both plastic wrapping and some cheese, which is 3. The cardboard box used to deliver the cheese to the retailer was also treated as waste. Now, let us find out what are the environmental impacts of cheese production. During the cheese-making process and at the retailer, CO2 was the largest contributor to global warming. The combustion of natural gas was the main source of the CO2 emitted at the dairy. At the retailer, the main source of CO2 was the use of gasoline during the transport from retailer to household. Next is acidification. The emissions that contributed most to acidification were NH3, NOx, and SO2. According to Cederberg, the ammonia emitted at the milk-producing farm contributed 119 grams SO2 equivalents per FU, almost exclusively through ammonia evaporation from farmyard manure. Emissions of ammonia and nitrate contributed the most to eutrophication during milk production. The ammonia evaporated from farmyard manure and the nitrate leached from the soil. Study found that environmental impact value of eutrophication potential for cheese products is 0.061 kPa for ek. Finally, the production of diesel contributes to photochemical ozone creation potentials in relation to the cheese-making dairy and at the retailer. 16% of photochemical ozone formation is released during cheese production. In order to make substantial improvements in the environmental performance of cheese production, it is necessary to mitigate the activities that contribute most to the environmental impact. From the dairy's perspective, an important improvement would be to decrease the amount of milk required to produce cheese. Identifying and minimizing the losses of milk during the production of cheese would decrease the consumption of milk without affecting the final product. On the other hand, consumers, too, could contribute by minimizing the wastage of cheese in the household and reducing car transportation from the retailer to the household. Most importantly, the cheese manufacturer must use biodegradable and recyclable packaging. In conclusion, it is undeniable that energy and fuel usage were the main contributors to many manufacturing and post-dairy plant environmental burdens, which involved activities such as storage, refrigeration, and transport. Manufacturing and packaging had the largest post-farm contribution, as their largest influence being on freshwater and marine eutrophication. That's all for this video. Thank you for watching.